Dear student, in today's lecture we start chapter number 5, Oscillations. Now what is oscillatory motion? In previous standard, you already learned different types of the motion. Oscillatory motion means to and fro motion. The motion of object, simply we can consider a few example. Motion of needle of sewing machine is oscillatory motion. Motion of bob of simple pendulum is oscillatory motion. Means many example we can give. The weightage of this chapter oscillation is 7 mark with option. So this is very important chapter and high weightage chapter in your board exam point of view. Now let me start the first article from this chapter, and it is periodic motion. So what is periodic motion? Let I tell you simple examples of the periodic motion. Motion of needle of sewing machine is a periodic motion. Circular motion, uniform circular motion is also a periodic motion. Or periodic means what? Basically, periodic means which is repeating. Day and night are periodic things. The motion which is repeating itself after equal interval of time, that motion is called as periodic motion. You can see here. Which repeat, the motion which repeat itself after definite interval of time is called as periodic motion. Many example we can give here. A body performing periodic motion repeats the same set of motion again and again. For example, when a body is moving in a circular motion, then if it start at A, then again after particular interval, the body is coming at again A. So it is a periodic motion. Then second example is motion of bob of simple pendulum. So if I consider this is a bob of the simple pendulum. So when it oscillate, then it repeat itself after equal interval of time. So the motion of bob of simple pendulum is a periodic motion. Now, the interval of time required to complete one set of motion is called as period. Period means what? Time required to complete one oscillation or one set of motion is the period. Now, uniform circular motion is an example of this periodic motion. Another type of motion is to and fro motion is a periodic motion. To and fro means what? Oscillatory motion. Oscillatory motion is an example of periodic motion. The simplest oscillatory motion is periodic. Simplest oscillatory motion is periodic motion, in which every particle moves to and fro about its mean position. It's simple word. In simple word, you remember, oscillatory motion is a periodic, but all periodic motions are not oscillatory, that you remember. Now next article is equilibrium position. Now what is equilibrium position? So that we have to learn here. Now if you see the diagram very carefully, so equilibrium position means you can see here. So this is the equilibrium position. So the position of this bob at B, at point B, is the equilibrium position. Equilibrium, or it is also called as mean position. Okay? It is a mean position, and these A and C are the extreme position of bob of simple pendulum. So oscillating bodies comes to rest at their equilibrium position when bob is suspended from rigid support. It goes to extreme position and then again come to mean position. And this mean position is also called as equilibrium position. I hope you understood what is equilibrium position. after the equilibrium position, we have to learn spring mass oscillator. The mass and spring system is useful model for a periodic system. Let me consider one example. So in that we are considering a mass and spring. You can see here the motion of this body. So to and fro motion. To means once to this side and after some time to that side. So this is the equilibrium position. You can see here this is the equilibrium position. This object is moving to and fro of the equilibrium position. Once towards right side, once towards left side. Now if you see here the two things, restoring force and the position or displacement basically. So displacement. Their direction you can see here. When this block is moving towards right, the displacement is in this direction. But that time the spring develops some restoring force and which is in opposite direction. You can see here the restoring force that time is towards left side. So here these two arrows gives the direction of displacement and restoring force. So what you can observe by this diagram, you can observe that the displacement and restoring force are oppositely directed. They are oppositely directed. Take it. Now here you remember one thing, we already learned elasticity. So inside the spring restoring force is developed, and that restoring force is because of the displacement of the block, and that restoring force depends on the displacement. Larger the displacement of the block, larger the restoring force developed in a spring. So we can write restoring force proportional to displacement, and they are oppositely directed, so we can put minus sign. And if you put the constant, so we get this equation, F is equal to minus kx. Okay, you can see some more diagrams here. So this is the equilibrium position. So when it is in equilibrium position, no restoring force. So spring doesn't exert any restoring force on this block. But when we pull this block with some distance x towards right hand side, then inside the spring some restoring forces develop which is in left hand side. So direction is opposite. And because of that restoring force, this block pulled towards left hand side. And again when it is at this position, some restoring forces develop, and because of that this block is pulled toward this side and the motion continues. So simple equation we get here, restoring force directly proportional to displacement, both are oppositely directed. So minus sign. Or we can write the constant here, and the constant is k. So where k is called as force constant, where k is called as force constant. Okay. Now this type of motion is called as linear simple harmonic motion. It is called as linear simple harmonic motion. Now let me define it. Now what is linear simple harmonic motion? So linear simple harmonic motion means the motion where f and x, they are proportional and they are in opposite direction also. That motion is what? Linear simple harmonic motion. Simple harmonic motion is abbreviated as SHM. SHM. SHM means simple harmonic motion. Now pay attention here. Simple harmonic motion is a special type of oscillatory motion in which particle oscillate on straight line. Second thing, restoring force is always directed towards the mean position. Third one, magnitude of restoring force is proportional to displacement of the particles from mean position. So restoring force proportional to displacement, and it is directed towards the mean position. Restoring force is always towards the mean position. So here this relation we get, F is proportional to minus x. So we can write F is equal to minus kx. K is a constant, depends on elastic properties of the body, and that constant is called as force constant that we already discussed. I hope you understood this simple harmonic motion, because in this chapter repeatedly we are using the word simple harmonic motion. So simple harmonic motion means you must know. Now here the negative sign means that force and displacement are oppositely directed. That also we discussed. Now we have to learn a very important article, and it is differential equation of SHM. SHM means simple harmonic motion. And you note one thing here, simple harmonic motion may be classified into two types: linear simple harmonic motion and angular. Now here we are discussing linear simple harmonic motion. So differential equation of linear simple harmonic motion. Now we use same thing which we already know. So consider one body is performing linear simple harmonic motion. Then we can write F is equal to minus Kx. We can write F is equal to minus Kx. Then by Newton's second law, you know that Newton's second law of motion is F is equal to ma. So we have F is equal to ma. Now that F is equal to ma we substitute in equation number 1 instead of F. So we get here minus Kx is equal to ma. Minus Kx is equal to ma. So this equation we get. Now here acceleration we have to substitute. Now you know that velocity is dx by dt, and acceleration is what? dv by dt. So here if we substitute this v, then we get d square x by dt square is the acceleration. Okay? So that acceleration value we have to substitute in this equation. After that we get m d square x by dt square is equal to minus kx. Now next step, we transfer this m to the right hand side. So we get d square x by dt square is equal to minus k by m into x. Now this minus k by m we can shift to this side. So we get this formula: d square x by dt square plus k by m into x is equal to 0. But here k by m we can substitute as a omega square. So you remember here omega is under root k by m. Now how we get this omega is equal to k by m, that is coming in the next article. But you remember here, so omega is root k by m, so omega square is k by m. So this we substitute in equation number 4. So we get expression here, and this is a differential equation of linear SHM. This is a differential equation of linear SHM. Consider differential equation of SHM. Just we already derived this equation, d square x by dt square plus omega square x is equal to 0. Now we transfer this omega square x to the right hand side. So it is minus omega square x. Now here d square x by dt square is acceleration. It is acceleration. So we can write formula of acceleration. So this term is acceleration. So acceleration is equal to omega square x. Now in this chapter you note one thing here. Don't use a for acceleration. Now let I write here acceleration, full word. Now this is the acceleration. I hope you understood what is the acceleration. Now after the acceleration, we have to learn velocity. But before that, let I tell you two cases of the acceleration. The first case is case 1, at mean position. At mean position. Now what is mean position? Now let I tell you simple example. When particle is oscillating to and fro, then The central, this equilibrium position is called as mean position. And this extreme position, this is extreme. End position means extreme. So two extreme positions are there. At mean, displacement is 0 because we are measuring displacement of the particle from mean position. Now at extreme, two extreme positions are there. The right hand side is positive extreme position, and at that positive extreme position displacement is plus a. And towards left hand side it is a negative extreme position and the displacement is minus a. Now a is what? Small a is amplitude. Small a is amplitude, or you can use capital A also. Small a, capital A, generally we can write it for amplitude. Okay. Now at mean position, if I use small a for the amplitude, then at mean position x is equal to 0. Then how much is the acceleration at mean position? Let me substitute x0 in a formula of acceleration. So we get acceleration is equal to 0 at mean position. Now the case number 2. At extreme position. At extreme position, x is equal to plus minus a. Okay. So acceleration is equal to, okay, I use here a positive value. Okay. Is plus minus indicate only the direction, only towards which side. So x is equal to a. So here we get acceleration is equal to minus omega square a. So instead of x, I substitute here a. So we get this formula. Now you note one thing here. You note one thing. So acceleration at mean is 0 and acceleration at extreme is minus omega square a. So here the simple conclusion is acceleration is maximum at extreme. So this acceleration at extreme is also called as maximum acceleration. So the formula for maximum acceleration is equal to minus omega square a. In a problem, if the question is asked, find out maximum acceleration, means you have to find out this omega square a or minus omega square. I hope you understood this acceleration part. Now the next part is velocity. Next part is velocity. Now velocity of SHM. Again we consider the same equation, differential equation. Now you know that d square x by dt square is equal to minus omega square x. Now here we split up this term. This term we separated. D by dt multiplied by dx by dt. And this term is velocity. So we can write dv by dt is equal to minus omega square x. Now we can do some arrangement here. So here we multiplied by x and divide by x. So this dx get cancel, we get this term again. dv by dt is minus omega square x. So that we done for the simplicity only. Okay. Now here this dx we can shift to this side and this dv we can shift to this side. Means we get the next equation. Next equation we get dx by dx. Sorry, no need to shift here because already we are written accordingly. So this dx by dt, it is what? Velocity. Okay, and this dv by dx as it is. So we get this term. V dv by dx is equal to minus omega square x. Now we transfer this dx to right hand side. So here it is divided, to that side it is multiplied. So we get the term v dv is equal to minus omega square x, and this dx to this right hand side, it is multiplied. Now by using this formula, we have to obtain v, and v is the velocity in SHM. So how we obtain v? So let me integrate this equation. After integration, we get integration of v dv is equal to integration minus omega square x dx. But here this minus omega square is constant, so taken out. So integration x dx. So you know that integration x dx is how much? It is x square by 2. Integration v dv is equal to v square by 2. And plus constant of integration we can write. So here this integration v dv, we are written v square by 2. Then integration x dx, we are written x square by 2. And the plus c is a constant of integration. It is constant of integration. Now we have to find out this constant of integration. So at extreme position, at extreme, so at extreme position, what is extreme position? Just already I explained what is extreme position. So when particle is at extreme position, means at mean x is equal to 0. So at extreme, x is equal to a plus a, and to that side x is equal to minus a. Okay. When particle is following this to and fro motion, so at extreme, the velocity of the particle is 0. Because you know the simple example of the simple pendulum. So this is the mean position. When pendulum is oscillating, when it reaches to the extreme position, velocity decrease, here velocity is 0. Then it return back to the mean position. And again to move this side and velocity decrease, when velocity is 0, it moves toward the equilibrium position. Means at extreme the v is 0. In simple conclusion, you remember at extreme, means at x is equal to a, v is equal to 0. So here acceleration, sorry, this capital A is for amplitude. So here x is equal to this side minus a, and to this side plus a. We can use small a, capital A for this amplitude. So v is 0. Hence we substitute in this formula. So v is equal to 0 we have to substitute, and x is equal to a we have to substitute in equation 1. Then what we get? So we get 0 square by 2, 0 is equal to minus omega square a square by 2 plus c. Now this term we can shift to this side, left hand side. So we get a formula of c, and the c is given by this. C is equal to omega square a square by 2, and this c we can substitute in equation number 1. So this is the value of c that we have to substitute in equation number 1. After substitution, what we get? This v square by 2 is equal to minus omega square x square by 2 as it is. Okay. Plus c. Instead of c, we are written this omega square a square by 2. Now from this we can take the common. So what we can take common? So we can take these 2 common. So 1 by 2 common from both the side. Then this 2 get cancelled. Then we get v square is equal to, as well as from this right hand side we are taken omega square common. So as we take omega square common, we get minus x square plus a square in a bracket. So only first we are written a square and then minus x square. So this is v square. Okay, and taking square root of the both side, we get a final formula of the velocity of this SHM, and it is plus minus omega in a root a square minus x square. This is expression for velocity of SHM. Now here we are written the plus minus sign. The reason is plus omega having a square omega square, and minus omega also having a square omega square. So that's why plus minus omega is written here. Now after that we can learn the cases also. At mean x is equal to 0. Or first we write at extreme. At extreme x is equal to a. If I substitute x is equal to a, sorry, here we use capital A because for amplitude we use capital A. So x is equal to capital A. Now instead of this x I substitute capital A. Then capital A square minus capital A square 0. So v is coming 0. So that we already written here. So x is a, then v is equal to 0. Now case 2. At mean position x is equal to 0. As you substitute x is equal to 0, then this term get cancelled and we get a formula of v plus minus omega in a root a square. Root a square means a. So v is equal to plus minus a omega. And this is after velocity of SHM, we have to start new article from chapter oscillation, and it is displacement of SHM. Now consider the velocity formula. This formula we already derived in the last article. V is equal to plus minus omega under root a square minus x square. Substituting this, V is equal to dx by dt. We get, you know, that formula of the velocity v is equal to dx by dt, that we have to substitute. We get formula dx by dt is equal to plus minus omega under root a square minus x square. Now here let me rearrange the term. We send this bracket in the square root term towards this left side and this dt towards right hand side. Then we get term dx divided by under root a square minus x square is equal to omega dt. We have to find out x by using this. Now for that we can do one thing here. We can integrate both the sides of the equation. After integration of the both the side, we get integration dx divided by under root a square minus x square is equal to omega integration dt. Now this is the standard integration formula. If you already finish integration chapter in the mathematics, definitely you come to know that. So here this integration is equal to sine inverse of x by a. This omega as it is, and integration of this dt is t. Integration of this dt is t, and integration dx divided by under root a square minus x square is the standard formula of the integration that you have to remember. Those who don't have mathematics, you have to remember this is the standard integration formula. But those who have mathematics, definitely you have to learn these formulas in the mathematics. So we get formula here, sine inverse x by a is equal to omega t plus phi. So phi is the constant of integration here, and this phi depends on the initial conditions. Now here, if we transfer this sine inverse to this right hand side, it is sine, then it is sine omega t plus phi, and then a also we can shift to this right hand side, so a is divided here, then it is multiplied. So we get a formula x is equal to, we get formula x is equal to a sine omega t plus phi. So this is a formula for displacement of SHM. Now after this displacement of SHM, next article means here we have to learn the cases for the displacement. The case number 1, you know that at mean and at extreme displacement is how much? You know that at mean displacement is 0. At mean x is equal to 0. At extreme displacement is equal to a plus minus a. So that you already know. But listen, here in case number 1, we have to obtain if particle start its motion from mean position. If particle start its motion from mean position, then what is the formula of displacement that we have to write? Means here, if I consider this is a path, this is the extreme, this is a mean position, this is mean, and these two are the extreme position. So this is also extreme. Now if particle start at mean position, if particle start its motion from this mean position, then what is the formula of displacement that we have to obtain? Now pay attention. Yeah. So let me consider here when the time is 0. When time is 0, the particle is at its original position and particle is started from the mean position. When time is 0, particle is at mean. At mean, you know that x is how much? X is 0 in mean position. So when time is 0, we can say that particle is at mean. So x is also 0. Then that x and t we substitute in a formula of this displacement. And then whatever the formula we get, it is the formula of displacement when particles start from mean position. Now let me substitute here. And then we get here formula x, we get a formula. Now let me obtain like this way also. X is equal to this a sine omega into 0 is 0 plus phi, this term, and x is 0, so 0 is equal to this term we get. So 0 is equal to sine of phi. So phi is equal to sine inverse 0. So you come to know that sine of which angle is 0? Sine of 0 is 0. So you get phi is equal to 0. So when phi is equal to 0, when particle is at mean, means at mean phi is 0, that you remember. So here phi is equal to 0, that you remember. The second thing is if I substitute phi is equal to 0 in this formula of displacement, so x is equal to, we get a sine omega t plus phi is 0. So we get formula a sine omega t is the displacement. If particles start at mean position, this is the formula for displacement. Now let me obtain here in another way also. So you know that here phi is equal to sine inverse of x by a. If I substitute here in this equation, t is equal to 0 and x is equal to also 0. If x and t, if we substitute 0, then we get phi is equal to 0. ठीक है. Then substituting this value of phi in equation 1, we get, so x is equal to a sine omega t, and this is expression for displacement when particles start at mean position. Now similarly, the case 2, if particles start at extreme, if particles start at extreme, then how much is the displacement that we have to obtain? Second one is if particles start SHM from extreme position. So when time is 0, particle is at extreme. So we can write here. So we have when time is 0, particle is at extreme, and at extreme x is plus minus a. So by using that, if we substitute this in the formula of sine inverse, So sin inverse phi is equal to sin inverse x by a. Okay, this t is 0 here. Now here, after solving this, we get the phi is equal to pi by 2. Or in another word also we can simplify this equation. So this value you can substitute in this displacement also. So we get x is a is equal to a sine omega t plus phi. Then this a get cancelled. We get 1. 1 is equal to, and time is 0. So this omega t is 0. So sine of phi. So sine phi is equal to 1. So phi is equal to sine inverse of 1. And you know that sine of which angle is 1? Sine of 90 is 1. So phi is equal to 90 degree. So you remember here the phase. So when particle is at mean, the phase is 0. But when particle is at extreme, the phase is 90. This phi is the phase basically, 90 or pi by 2 you can write. If I substitute this pi by 2 in this equation number 1, then we get x is equal to how much? You can see here, let I write here, x is equal to a sine of omega t plus 90. Sine of theta plus 90 is cos theta. So we get formula x is equal to a cos omega t. This formula we get. And the same formula you can see now here. So here we get the phi is equal to 90 here, or we can write 270 also, or pi by 3 pi by 2. Okay, if we substitute this 90 value in the equation number 1, we get sine omega t plus 90, and it is cos omega t. So we get formula for displacement when particles started at extreme, and it is a cos omega t. So both the formulas are very, very important for the problem point of view. In any problem, if the question is there and if the information is there, if the particles start at mean or particles start at extreme, accordingly the formula of the displacement you have to use. Now extreme values we can see again. So when we are talking about displacement, the expression for the displacement is a sine omega t plus phi. This is a general expression for the displacement. Now in that, we can obtain the extreme values, means the two cases. At mean x is 0, because displacement we measure from the mean position, and at extreme displacement is a. So when we are talking about the velocity, the expression for velocity is omega under root a square minus x square. Now let me write the two values of the velocity at mean and at extreme. At mean, displacement is 0. So let me substitute displacement 0 in above equation. Then we get velocity is equal to plus minus a omega. And this is the maximum velocity. So we can use V max. Maximum velocity is given by this formula a omega. That we already learned in the previous article also. At extreme, x is equal to plus minus a. If we substitute x is equal to a, then v is equal to 0. So we get velocity is equal to 0 at extreme position. And it is the minimum velocity. Now the last one is the acceleration. So acceleration. Now at mean, you know that x is equal to 0. And if we substitute x is equal to 0, then acceleration is coming 0. So acceleration is minimum at mean position. And at extreme, you know that x is equal to a. If we substitute x is equal to a, then we get plus minus a. Then we get a maximum acceleration at extreme position, and it is plus minus omega square a. These are the extreme values of displacement, velocity, and acceleration. All the extreme values you have to remember for MCQ as well as problem point of view. Now, what is amplitude of oscillation? Basically, I will show what exactly mean by the amplitude. You can see the diagram here. So here this is the mean position and these two are the extreme. So this is negative extreme side and this is positive extreme side. So this block is moving in between these two positions. The maximum displacement of this block is called as amplitude. Now here in a diagram of SHM, so this is the extreme position. So this is also extreme. And this is a mean position. All the displacements are measured from mean position, that you know. In any problem, if the displacement is given, means if the distance from extreme is given, that is not the displacement that you know. Displacement means a mean position to the position of the particle. The distance between mean position and the position of the particle is the displacement. Now here, if we consider the particle is performing SHM on this path Mn, then displacement for this case is given by this formula. X is equal to A sine omega t plus phi. This is the displacement. Now, in that the value of this term sine omega t plus phi is plus minus 1, maximum value. When this sine omega t plus phi is maximum, then X is called as a maximum displacement, and that maximum displacement is amplitude. Simple word, we can write a definition of the amplitude. The maximum displacement of a particle performing SHM from mean position is called amplitude of SHM. Now you can see here in animation also the maximum displacement. So this block is moving, this is the mean equilibrium position, and the block is moving up to this maximum position. So this distance is called as amplitude. Maximum displacement from mean position is called as amplitude. I hope you clearly understood what exactly mean by the amplitude. And in this chapter, amplitude we are denoting by the letter capital A. Now next term is the period of SHM. What is period? Everyone know that. Period means time taken by particle to complete one oscillation is the period. Time taken by particle to complete one revolution is period. So it's a time. Period is a time basically. Now what is the formula of the period in SHM? That formula also we have to obtain here. So basically a definition of the period is given here. Time taken by particle performing SHM to complete one oscillation is called period of SHM. Now displacement formula we already know. X is equal to A sine omega t plus phi. This is the displacement. Now here we substitute. If I consider time is equal to t plus 2 pi by omega. Let me consider t is equal to t plus 2 pi by omega. Then what is the displacement that we obtain? Let me substitute this value of the time in this equation and we obtain how much is the displacement. Then we get equation x is equal to a sine in a bracket omega, then t we are written here, t plus 2 pi by omega, bracket complete, then plus phi, bracket complete. So we substitute only the value of t and then we have to simplify this. After the simplification, so let me multiply this omega to the inner terms of the bracket. So we get omega t plus omega get cancelled, we get 2 pi and this phi as it is. So we get this formula of x. Now here if you see this formula very carefully, here 2 pi is coming. And you already learned one chapter related to the angle in the 11th standard. So you know that the value of sine is repeating itself after 2 pi. After 2 pi, the sine value of the sine repeated. After 2 pi, 4 pi, 6 pi, okay? The value of sine is repeating. So here, this above equation we can write like this. So x is equal to a sine omega t plus phi. So as we substitute, time is equal to t plus 2 pi by omega, then we get the displacement is a sine omega t plus phi. So initially we have written this displacement. Then after substitute, after some time t plus 2 pi by omega, we get this is a displacement. And if you see these two displacement, we get the same formulas. It means that in this time, the particle completed one oscillation. Particle completed one oscillation. So that time is the period. This result show that particle is at the same position after this time 2 pi by omega. That means that particle complete one oscillation in time 2 pi by omega. So this time is called as period. So we can write period is given by this formula 2 pi by omega. So in circular motion also the period is given by the same formula. So here also in SHM the period is given by the same formula 2 pi by omega. Now from this equation, we can write omega square is k by m. And this k by m is acceleration per unit displacement. Because you know that acceleration is equal to omega square x. So that everybody know. So k by m represent acceleration, means omega square. You can write omega square is what? A by x. So this is the first equation. Second equation of the omega square is this. Second equation of the omega square is this. If we compare these two equations, means here omega square is acceleration divided by displacement. So we can write acceleration per unit displacement. Acceleration per unit displacement. And acceleration per unit displacement is k by m. Simply because omega square is equal to a by x is equal to k by m. So these are the equivalent formula. So here period we can write. You know that formula of the period is what? 2 pi by omega. So this is the formula of period. So here t is equal to 2 pi by omega. Instead of omega we can write acceleration per unit displacement. So we can write omega is as a under root acceleration per unit displacement. So we get here t is equal to 2 pi upon acceleration per unit displacement. In another word also, you know that acceleration is omega square x. So here omega is acceleration divided by displacement in a root. Okay. So period is what? 2 pi by omega. So 2 pi divided by omega is what? Acceleration per unit displacement. Same formula we get here. So a by x, a means acceleration, x means displacement. The same formula we can write in word 2 pi upon under root acceleration per unit displacement. Okay, this is the formula of the period. So you can remember the period is given by 2 pi by omega, or t is equal to 2 pi upon acceleration per unit displacement. So this is expression for period. In a problem we have to use these formulas. Also, as this omega square is k by m, so omega is root k by m. So period you can write 2 pi by omega. So if I substitute omega 2 pi upon under root k by m, or we can write 2 pi under root m by k, is the formula of period. Now next article is frequency of SHM. Now what is frequency first? Frequency means the number of oscillation performed by a particle per unit time is called the frequency. In previous standard also you already learned frequency means number of oscillation per second. In 1 second, if the particle complete 3 oscillation, then 3 is the frequency. So oscillation per second is the frequency, or per unit time is the frequency. Now here you know that frequency is given by formula. Frequency is given by formula 1 by period or 1 by capital T. And capital T formula just now we already derived. Frequency we can represent by symbol small n. So formula of the frequency we get 1 by capital T is the first formula in term of period. Second in term of omega, omega upon 2 pi. Third one in term of k and this m, so 1 upon 2 pi under root k by. So these are the different formulas of the frequency which you have to remember. So you remember the formula of T, only that formula reciprocal you have to write as a frequency. Now after that we have to learn one problem based on this article. Now see here, body of mass 0.2 kg. So this is the mass. Perform linear SHM. It experiences a restoring force 0.2 Newton when its displacement from mean position is 4 cm. So this is a force, restoring force. And displacement from the mean position is 4 cm. I mean this is the x displacement. Determine force constant means K you have to find out. Period of SHM means T you have to find out. And acceleration means A you have to find out, small a. Now let's see the solution here. First we write the formula of force constant. So F is equal to minus Kx, this formula you know. But we are considering only the magnitude. So no need to put the minus sign. So by using that formula, hence F is equal to Kx. So K is equal to F by X. Now we substitute F and X in one system. So F is 0.2 and X is 4 centimeter. 4 centimeter means 4 into 10 raised to minus 2 or 0.04 meter. So after substituting and solving these values, we get K is equal to 5 Newton per meter. Now next one is period. Period is given by formula 2 pi by omega, or you can use this formula 2 pi under root m by k. Now m is given, k is given. Now we have to substitute, and after substitution we have to do the calculation. So after solving this we are getting 0.4 pi. So this value is in term of pi. So 0.4 pi second is the answer here. Now the third one is the acceleration. Third one we have to find out acceleration. And acceleration is given by formula minus omega square x. Omega you know that under root k by m. So omega square is k by m. And this x as it is. Everything is given here. Now we substitute the values and do the calculation. Then we get answer minus 1 meter per second square is the acceleration. This is the value of acceleration. Now I hope you understood this problem. In today's lecture, so it is a problem from exercise, problem from textbook. A particle performs linear SHM of period 4 seconds. So this is period. And amplitude 4 centimeter. Find time taken by it to travel a distance of 1 centimeter from positive extreme position. So listen, you have to find out time to travel distance 1 centimeter from positive extreme. So here, a particle is following SHM. So this is extreme position. So this is a positive extreme. So here x is equal to plus a. And this is the mean position. So total here amplitude is 4 centimeter. And from this extreme position, 1 centimeter distance, the particle has to travel, and you have to find out time for that. So we already learned article. One article in that we learn two cases. If particle start at mean, if particle start at extreme. Two formulas of the displacement we learn. So if particle start at extreme, the displacement is given by formula A cos omega t. So we have to use this formula. In that, we have to find out time to travel a distance 1 centimeter. Now how much is x here? So x is this. This is x. Now this is 1 centimeter and this is 4 centimeter. So 4 minus 1 is 3 centimeter is x. So here x is equal to 3 centimeter. Now A is the amplitude. Amplitude is given 4 centimeter. Omega. So instead of omega they given period. So omega we can write 2 pi by t. So 2 pi by period is 4. So pi by 2 is omega. Now these values you have to substitute in this, and you have to do the calculation for t. So you have to find out small t is equal to how much. The solution here, we know this formula x is equal to a sin omega t. And if particle perform SHM from extreme position, then displacement we can write 3 centimeter. So displacement is 3 centimeter and the extreme position phase is pi by 2. Okay? Or you can directly use this formula also, x is equal to a cos omega t. Then also it's okay. And then after substituting these values, the answer is coming this 0.46. Just I told you, you can use this formula a cos omega t. X is here 3, a is 4. Cos of 2 pi by t is 4 into small t. So it is coming 3 by 4 cos of pi by 2 into t. So it is 0.75 cos pi by 2 into t. Cos inverse 0.75 is pi by 2 into t. So it is coming 41.4. I think 41 it is coming is equal to pi by 2 into t. So t you can keep it to this side and 2 you can shift to this side. Pi is 180. So you will get answer 0.4601 is equal to t. And this is the answer. Next example is a particle performing linear SHM with period 6 seconds, means capital T is given, is at positive extreme position. It is at extreme position that you know. At t is equal to 0 means it starts from positive extreme position. The particle is found to be at a distance of 3 centimeter from this position. Particle is at a position 3 centimeter from extreme at a time 7 seconds before reaching the main position. Find the amplitude of SHM. you have to find out amplitude of the SHM. Now here again the formula is same. So time is 0, the particle is at extreme, so phi is pi by 2. Okay? Or you can directly write x is equal to a cos omega t also. So displacement. So here it is 3 centimeter from extreme. So amplitude is not given. So x is equal to a minus 3. Amplitude minus 3 is the x. So that we have to substitute here. So we can substitute here in this formula. X is equal to a minus 3 is equal to a cos omega t. That omega we can write later on 2 pi by t, and we can simplify this equation. So a minus 3 is equal to a cos omega is 2 pi by capital T into this small t. Now after substitution this we can write a minus 3 by a is equal to cos of 2 pi by capital T is here given 6 second. 6 into this small t is 7 second. After simplification of this you can find out amplitude of SHM. And this you can write cos of 7 pi by 3, you can write cos of 2 pi plus pi by 3. The cos value is repeating itself after 2 pi angle, so you can write it is equal to cos of pi by 3. So this a minus 3 divided by a is cos pi by 3. Cos pi by 3 means cos 60. So cos 60 is 1 by 2. So you can get a formula a minus 3 by a is equal to 1 by 2. After doing the cross multiplication, you will get the answer. So listen, this is the mathematics. You can solve this by any method. So whatever the method you feel easier, you can use it. You already learned the angle chapter in the 11th standard. So 2a minus a is equal to 6. So a is equal to 6 centimeter. You can see the answer here. It is 6 centimeter. Next example, the speed of particle performing linear SHM are 8 centimeter per second and 6 centimeter per second. Means this is V1 and this is V2. At respective displacement 6 centimeter and 8 centimeter. Find period and amplitude. Listen here. The speed formula is plus minus omega under root a square minus x square. This is the formula. So here this speed is given, v is given, and x is given. You have to find out a. Take the ratio. Omega is same here. Omega get cancelled. So here let I tell you. You can write equation 1 and equation 2. So here v1 is in given. Let I tell you the given, then you can start solving this. Given. So V1 is 8 centimeter, V2 is 6 centimeter. So displacement 1, x1 is equal to 6 centimeter. So here it is per second, sorry. And x2 is 8 centimeter. Okay. Now you can use here the formula. So V1 is equal to omega under root a square minus x1 square. Means it is coming 8 is equal to omega under root a square minus x1 is 6 square. Equation number 1. Similar manner, second equation V2 is equal to omega under root a square minus x2 square. So by using that, V2 is 6 is equal to omega under root a square minus x2 is 8 square. Equation number 2. Divide equation 1 by 2. By 1 divided by 2, this omega get cancelled. You can find out a is equal to how much. As you get a, that a you can substitute in equation 1 or equation 2. Find out omega. As you get omega is 2 pi by t that you can use, and you will get the period. So here the formula is V is equal to omega under root a square minus x square. So we can write here the two speeds are given, two velocities, two displacements are given. After substituting, we get equation 1 and equation 2. After taking division, we get this one. Let me simplify it. 4 by 3 is equal to this. This omega get cancelled. And after taking square of both the sides and simplifying it, we get a is equal to 10 centimeter. After getting amplitude, we have to substitute this amplitude in a formula of V, in the first formula or the second formula. Okay, first formula is V1 is equal to omega under root a square minus x1 square. So here a we substitute. A is 10. And here x is 6. This is the x1. And this is x2. Then after simplification of this, we get t is equal to t, we get 2 pi. This 8 get cancelled and t is equal to 2 pi. 2 pi means 6.28. 2 into 3.14. It is coming 6.28. Now see the next example. Maximum velocity of particle performing SHM is 6.28 centimeter per second. This is V max. The length of the path. Listen, in SHM, this is a path length, extreme to extreme. And this is A and this is A. So total 2A is the path length. Okay. 2A is 8 centimeter. Means A is 4 centimeter. You have to calculate period. So V max is 6.28. Okay. A is 4 because I told you 2A is 8. Hence A is equal to 8 by 2 is 4 centimeter. So maximum velocity formula is, this is the maximum velocity formula. Maximum velocity is A omega. So here omega is not given. That we have to find out. And by that omega we have to find out period. So omega is V max by A. And then you can substitute omega is 2 pi by T. So V max is 6.28 and A is 4. So 6.28 and pi both are same. So these get cancelled. So we get T is equal to 4 seconds. So next example. Maximum speed of particle performing linear oscillation is 0.08 meter per second. Maximum speed means a omega is given. So this is a omega. If maximum acceleration formula is a omega square. So a omega square is 0.032 meter per second. So you have to find out period. And second one is amplitude. So listen. So let I tell you the hint here. A omega square is 0.32. Equation number 1. Second one is A omega is 0.08. It is equation number 2. So find out omega by equation 1 divided by equation 2. You will get omega. So by omega, you can write 2 pi by t is equal to this. And by using that, you will get period is equal. As you get period, amplitude you have to find out. This is the first point. The first point is period. Second point is amplitude. Amplitude you can find out by substituting this omega in equation 1 or equation 2. So equation 1 we can use. So equation 2 we use. A omega is 0.08. So A is equal to 0.08 by omega. So by this you will get amplitude. In meter you will get. Substitute the values and try it. So here solution is after taking the division of this maximum amplitude and maximum velocity. You remember here maximum amplitude divided by maximum velocity is angular velocity. So omega is 2 pi by t. And this 2 pi by t is equal to this. So we get t is equal to 1.57. Now after that we can use the formula of maximum velocity. In that omega is again 2 pi by t. We substitute here t, and then after simplification we get a is equal to 2 centimeter. Is the amplitude. So what is phase? So very important term. So phase gives idea about initial state of the oscillation. So listen, basically state of oscillation is given by the phase. Means where the particle is there, that we come to know by using a phase. In order to know the state of oscillation in SHM, we need to know the displacement, means the position, the direction of velocity and oscillation number at that instant of time. Now let I tell you here the angular displacement in this phase is given by this formula. Theta is equal to omega t plus phi. And this is called as phase angle. Now let's see the special cases here. So what exactly mean by the phase 0? So listen, phase 0, it indicates that particle is at mean position. Where the particle is mean position. So in the cases when we learn, when particles start at mean and particles start at extreme, we learn two cases. That time we come to know that if phase is 0 means particle is at mean position. And listen, phase 0 it means that particle is moving to the positive side, positive extreme side. So here when we are talking about the SHM, so it has mean position and two extreme position. So this is a positive extreme position where displacement, maximum displacement is plus a, and here it is minus a. Now phase angle 360. Theta is 360 or 2 pi. It means that particle is again coming to the mean position, and it starts second oscillation. It starts second oscillation. Means when the particle is at mean, x theta is equal to 0. Again it moves to this side, and again come to this point. Then theta is 360 or 2 pi. And again after that it means one oscillation is completed, and it is the beginning of the second oscillation. Now the case 2. The phase is 180 degree or pi radian. It indicates that during its first oscillation, particle is at mean position. Particle is at mean position and moving to the negative extreme position. Means when it is 0, particle start here, it moves to this side and again coming at mean point. Then that time phase is 180. And now it is moving towards this negative extremity. Similar state in the second oscillation will have phase. Theta is equal to 360 plus 180. Or we can write 2 pi plus pi radian. And so on for successive oscillation. Listen, when again the similar point, particle is coming at this mean position and started going towards negative side. So plus 360 we can do. 180 plus 360 is the second oscillation it starts. Then again 360 plus 360 is the next oscillation. Means one oscillation means 360 degree. The next case is the case number 3. If phase angle is 90 degree or pi by 2 radian, it indicates that particle is at positive extreme position during the first oscillation. For the second oscillation, it will be 360 plus 90. Then the second oscillation, or 2 pi plus pi by 2. And so on for the successive oscillation. Now next one is, if the phase is 270, it means that particle is at negative extreme position during the first oscillation. For second oscillation is 360 plus 270, or we can write 2 pi plus 3 pi by 2 radian, and so on for the successive oscillation. I repeat again in simple word here. So at mean position, theta is 0. It is moving towards the positive extremity. When it reach here, theta is equal to 90. Okay? You can see here, it is 90, means where it is positive extreme. Then again when it start moving back, then when it comes to this position, theta is 180. So theta is 180 means it is again at mean position. You can see here theta 180 means it is at mean position and moving towards negative. Now it is moving to this side, and when it reaches to this negative extremity, theta is equal to 180 plus 90 is 270 degree. 270 means it is at negative extreme. You can see here 270 means negative extreme position. You can see case number 4. Then again I will use the different pen now. Again it come to this point, it start moving to this side and come here. Then theta is 270 plus 90 is 360. 360 means it is coming at mean. You can see here 360 means it is in the mean position and this beginning of the second oscillation, and so on. Let's see an example based on this. Describe the state of oscillation if the phase angle is 1110 degree. Now let's see the solution here. So 1130, that we write in a multiple of 360 plus something. So 3 into 360 plus 30 is 1110. So in 1 means, it means that here the 3 complete oscillation and then 30. Okay. So listen. So here you remember. So here x is equal, theta is equal to 0. So here theta is equal to 90. 3 into 360, it means that 3 oscillation plus something indicate 4th oscillation, some part. Now, if we substitute here, x is equal to a sine omega t. So here phase omega t is 30 degree. If we substitute here, then we get x is equal to a sine 30. Sine 30 is 1 by 2. So a by 2. So x is equal to a by 2. Means let I show it by blue line here. X is equal to a by 2 means here theta is 30 degree. Between these two, this phase is 30. So here it is 0. So between this mean and extreme, it is, means x is equal to a by 2, it is 30, and x is equal to a, it is 90. Thus phase angle indicate that this 1110 degree indicate that during its 4th oscillation the particle is at plus a by 2 and moving to the positive extreme, means it reached to this position. You can see here, I will show it by dot. So it reached at the middle position, x is equal to a by 2. Now next example is, while completing its 3rd oscillation during linear SHM, a particle is at minus root 3 by 2 a, heading to the main position. Determine phase angle. Now here let's see the solution here. So here x is equal to, we use the formula x is equal to a sine omega t, or a sine omega t means the phase. So this omega t indicate total phase. Now if we substitute, so this is the formula. By using this formula, we can determine here theta is equal to this pi by 3. Theta is equal to pi by 3. Now, or we can write this theta as a pi plus pi by 3 or 2 pi minus pi by 3. So both are equivalent to this. But here from negative side, the particle is heading to the main position. Here they given in a problem. Particle is heading to main position. Thus the phase angle in the 4th quadrant. Means obviously this is the right one. So we can write theta is equal to 2 pi minus pi by 3. And the value of this angle repeated after every 2 pi. So theta is, we can write, it is a 3rd oscillation and the phase angle is, so in 2 oscillation, 2 into this 2 pi plus this theta 1, and this is theta 1. That after substituting we get 4 pi plus 2 pi minus pi by 3. So 4 pi plus 2 pi, it is 6 pi. So 6 pi minus pi by 3. After solving it, we are getting 17 by 3 pi is the phase angle. In this lecture, we start article composition of SHM. So let me consider two SHM having same period, traveling in same straight line, same period, same straight line, but they having different initial phases and different amplitude. Then we write the two equations here. So we know the equation of SHM. In the previous lectures, we already obtained formulas for the SHM. Now displacement equation of two SHM are given as follow. So the first equation is x is equal to a1 sine omega t plus phi 1, because we consider here different amplitude. So amplitude of the first SHM is, I consider a1 here, and initial phase is also different. So initial phase is phi 1 for the first one, and second one is phi 2. So second equation is x2 is equal to a2 sine omega t plus phi 2. So we get two equation for SHM. Now we have to consider composition of these two SHM. When these two SHM we consider, then the resultant displacement of these two SHM is given by formula. So we get resultant SHM by formula x is equal to x1 plus x2. So this is x1 and this is x2. Now let me substitute x1 and x2 in this formula. So after substitution, we get here x is equal to a1 sine omega t plus phi 1 plus a2 sine omega t plus phi 2. Now this is a mathematical step. This we have to elaborate by using a formula. In mathematics, you already learned this formula: sine of a plus b is equal to sine a cos b plus cos a sine b. By using this, we have to expand above equation. Now this sine omega t plus phi 1 we have to expand, as well as sine omega t plus phi 2 we have to expand by using this formula. So we get equation x is equal to this sine omega t cos phi 1 plus cos omega t sine phi 1, and this a1 we multiply to every term, so we get this equation. Now similarly, the next bracket also in this next one. So a2 into sine omega t plus into cos phi 2 plus a2 cos omega t sine phi 2. Now you can see here the equation very carefully. From this term 1 and term 3, we can take here sine omega t as a common. We can take common term, and which is sine omega t. Here also sine omega t is there. So after taking this sine omega t common, we get, and if we see this term, second and the term 4, from these two, we can take cos omega t common. So from 1 and 3, sine omega t, and 2 and 4, cos omega t we have to take common. Then we get the equation. See here, sine omega t we are taken common, then in a bracket we get a1 cos phi 1 plus a2 cos phi. Then as we take cos omega t common, then we get a1 sine phi 1 plus a2 sine phi 2. So this is the basic mathematics. Then after that, we get here lengthy equation. So very lengthy equation. So let me do here some substitution to reduce the equation. So instead of this bracket, a1 cos phi 1 plus a2 cos phi 2, we substitute something. And we substitute instead of this first bracket r cos phi. Sorry, r cos delta. So we substitute r cos delta instead of this bracket. Similarly, you can see the second bracket. Instead of this second bracket, we substitute r sin delta. Listen, any equation we can write in the form, this is the amplitude, then sine cos, and then phase. Okay? Amplitude, cos, and then phase. So we can write this equation in the form of, so R is the resultant amplitude, cos, and the resultant phase is the delta. Similar manner, if you see this second bracket, amplitude A1, sine initial phase phi 1, amplitude 2, initial phase 2. Okay, so instead of this, we can write resultant amplitude, sine, resultant phase. Then after that, we get equation. So instead of this bracket, we substitute R cos delta, and instead of this bracket, we substitute R sin delta. Then we get a formula. R we can take common from both the side, and we get equation. X is equal to R in a bracket sin omega t cos delta plus cos omega t sin delta. So this equation we get. Now here, so this sin omega t cos delta plus cos omega t sin delta. This is expansion of the term sin omega t plus delta. Sin omega t plus delta by using this formula. So here this formula we use. So we get formula here. X is equal to R sin omega t plus delta, and this is the resultant displacement. In this equation, this R is resultant amplitude, and this omega t plus delta is the total phase, and this delta is the phase angle. Now here we have to obtain expression for R as well as expression for delta. Both the expressions we have to obtain. So the next article is resultant amplitude, means expression of capital R. Now we have these two equations, equation 1 and equation 2. These two equations we already seen in the previous page. Now here we can do some mathematical operation, and it is squaring and adding equation 1 and 2. If we square and add equation 1 and 2, this is equation 1, this is equation 2. If we square and add, then what we get? So on one side we consider this side first. So we get R square cos square delta, the R square sin square delta. So this is the left hand side. Now we consider this side. Now this bracket square plus the second bracket square. Now we have to use here a plus b bracket square expansion. You know that it is a square plus b square plus 2ab. That bracket square expansion we have to use, as well as we have to try to minimize this equation, and we have to obtain formula of this delta. Now after that, so here we get R square cos square delta plus R square sin square delta, this term. Then to this side, we get A1 square cos square phi 1, means this term square, plus the second term square, A2 square cos square phi. Then 2, A1 A2 into cos phi 1 cos phi 2. Means we use here the expansion of a plus b bracket square, a square plus b square plus 2ab. Okay. By using that, we expand here this bracket, the first bracket. Now second bracket, again by using the same thing. So here we get a1 sin square phi 1, the first term square, plus second term square, a2 square sin square phi 2. Then twice a1 a2 sin phi 1 sin phi 2. we get here. Now here we can take some common terms to reduce the equation. So from these two we can take r square common. As we take r square common, then in a bracket we get cos square delta plus sin square delta. Then after that, from this term and this, we can take a1 square common. So in a bracket we get cos square phi 1 plus sin square phi 1. After that, from next term, means from this term and from this, we can take a2 square common. So in a bracket cos square phi 2 plus sin square phi 2 we get. And the last one is this one and this one. We can take common twice a1 a2. Twice a1 a2 we can take common. Then in a bracket we get cos phi 1 cos phi 2 plus sin phi 1 sin phi 2. Now let me write the equation after taking these commons. So here we get this term. Then after taking a1 square common from these two we get this. After taking a2 square common we get this. After taking twice a1 a2 common we get this equation. Now here we have to substitute. You know that this equation cos square delta plus sin square delta is coming 1. So this is 1. As well as you know that here also cos square phi 1 plus sin square phi 1. So it is also 1. So this cos square phi 2 plus sin square phi 2, it is 1. Okay. So let me substitute. As well as this term, expansion of this, we use this equation. So cos A cos B plus sin A sin B, it is equal to cos A minus B. These formulas you already learn in the mathematics. So this term we can write here cos of phi 1 minus phi 2 we can write instead of this. So after substituting this, we get a final formula here. And it is r square is equal to a1 square plus a2 square plus twice a1 a2 cos phi 1 minus phi 2. But here we are given the heading here, we have to obtain expression for resultant amplitude, capital R. And we get a formula of r square. So let me write the formula of r. So r is equal to inner root a1 square plus a2 square plus twice a1 a2 cos of phi 1 minus phi 2. This is expression for resultant amplitude. In any of the question, resultant phase, which we can represented by a symbol delta. Now here again the same equation we have to use equation 1 and equation 2. And let me do the mathematical operation dividing equation 2 by equation 1. We can divide equation 2 by equation 1. We get. So after the division of equation 2 by equation 1, we get this equation. So this upper side you can see here, this is the equation 2 divided by this is equation 1. Then here r get cancelled. Sine divided by cos is tan. So tan delta we get to this left hand side. Right hand side as it is. But we have to find out here this phase delta. So we transfer tan to this side. So we get delta is equal to tan inverse in a bracket a1 sin phi 1 plus a2 sin phi 2 divided by a1 cos phi 1 plus a2 cos phi. And this is expression for resultant phase. The first special case is here. If two SHM are in phase. In phase means they're having a same phase. In phase means same phase. If they're having a same phase, means phi 1 and phi 2 is same. If phi 1 and phi 2 both are same, it means that The difference between phi 1 and phi 2 is 0 degree. Then cos of 0 is 1. Now let me substitute this in a formula of R. You know that R is equal to, in a bracket, a1 square plus a2 square plus twice a1 a2 cos of phi 1 minus phi 2. In this equation we have to substitute. Okay. After substitution we get this formula. a1 square in a root a1 square plus a2 square plus twice a1 a2. Now this is the expansion of a bracket a1 plus a2 bracket square. So here you can write here it is equal to. So here let I write one more step. So in a bracket a1 square plus a2 square. So you know that a1 plus a1 plus a2 bracket square. Huh? So a1 plus a2 bracket square expansion is a1 square plus a2 square plus twice a1 a2, and you can see here the same. So in a root a1 plus a2 bracket square means it is equal to a1 plus a2. So resultant amplitude we get a1 plus a2 if the two SHM having a same phase, or we can say that they are in phase. In that also, if both the SHM having same amplitude, if we consider that they having same amplitude means A1 and A2 both are same. If A1 and A2 both are same, we can represent it by A. Then if I substitute here A1 and A2 as A, then here we get A plus A is 2A. This is the resultant amplitude. Now case 2, if two SHM are out of phase. Two SHM are out of phase. Out of phase means that the phase difference between these two is 180. Phase difference is 180. It is also called as opposite phase. It is also called as opposite phase. Okay. Opposite phase means you know that one is moving to this side and one is to this side. So the angle is 180 degree. Okay. If two SHM are in opposite phase or out of phase, then phase angle is 180. And cos 180 is minus 1. Okay, let me substitute cos 180 minus 1. Then what we get here? So in a formula of capital R, we have to substitute. Then we get formula of capital R in a root a1 square plus a2 square minus twice a1 a2. Because this is coming minus 1. So this is minus 1. Cos 180 is minus 1. So here minus sign is coming. Now this is expansion of listen here a1 square plus a2 square minus twice a1 a2. It is the expansion of in a bracket a1 minus a2 bracket square. So we can write here in a root a1 minus a2 bracket square. So in a root a1 minus a2 bracket square means a1 minus a2 simply. Okay. So this is expression for resultant amplitude. So here we are written modulus, means we are considering the magnitude only. Now here, if I consider here a1 and a2 both are same and equal to the a, then if you substitute a1 and a2 both are same, then a minus a is 0. So we get resultant amplitude 0. So here you remember one thing, if two SHM are out of phase, or you remember opposite phase. If they are in opposite phase or out of phase, then resultant amplitude is a1 minus a2. And if both the amplitudes are same, then the resultant amplitude is coming 0. ठीक है. If two SHM, here it is not out of phase, huh? If two SHM perpendicular to each other, means here the phase difference phi 1 minus, if phase difference is 90, if phase difference between two SHM is 90, then cos of 90 is coming 0. Cos of 90 is coming 0. Then after substitution, so here if we substitute this as a 0, then 0 into this, we get everything get cancelled. So we in a square root, we get a1 square plus a2 square. So we get this. Now further, if a1 and a2 both are equal, if they are equal, then let me substitute in a root a1, sorry, a square plus a square in a root 2a square, or we can write root 2a. So we get resultant amplitude root 2a. So this is resultant amplitude if the phase difference is 90. Energy of SHM is the new article. Energy of SHM means what? We have to obtain expression for kinetic energy, then potential energy, then total energy. These three expressions we have to obtain. So we consider a particle performing SHM as shown below. So let we consider particle is performing SHM with the amplitude is A. So amplitude is A. Now particle is at any point P, which is at a distance x from the mean position. Then velocity of particle at displacement x is given by formula. You know that velocity is given by formula v is equal to omega under root a square minus x square. This is the velocity. Now here, by using that we can write kinetic energy. Kinetic energy is half mv square. So in that we substitute. After doing the square of that, we get here m omega square plus, oh sorry, omega square in a bracket a square minus x square. But we already learned one formula here. That formula is a formula of omega. Omega is, or omega square is a by m. So in the beginning only we learned this formula. So here m omega square is equal to k. So instead of this m omega square we can substitute k also. So we get this formula for kinetic. You remember both the formulas for kinetic energy, this formula as well as this. So this is the first expression and this is second expression. So this is in term of m and omega and this is in term of k. So we get formula for kinetic energy here. 1 by 2 k in a bracket a square minus x square. This is kinetic energy at displacement x. Now we obtain potential. Now we consider a restoring force. The restoring force is given by formula F is equal to minus kx. Negative sign indicates that this restoring force and displacement are oppositely directed. Now, the external work done during this displacement, some displacement is occur, definitely some work is done to displace that particle. So the external work done during this displacement is, work done is equal to, work done is given by formula force into displacement. So we can write here the formula of work done is equal to, so work done we can write like this, dW is equal to minus F into dx. Now as we substitute this f is already minus, so minus minus we get plus, so kx dx. So this is the work done. The total work done during the expansion from means O to P. We have to displace a particle from O to P. The total work done we have to find out from a displacement from 0 to x. So the limit here we put. The total work done we get by integrating this work done within an limit 0 to x. So here it is kx dx. K is a constant taken outside. So we get k integration x dx. Integration x dx is how much? X square by 2. After substituting this limit, we get x square by 2. So 1 by 2 kx square we get. So it is written here. Listen, k is a constant that is taken out, and you already know the integration. You already learn in the mathematics. So this is the basic step. So here we get work done. This should be the potential energy. This work done should be the potential energy. So instead of this work done, we use potential energy. So we get a formula of potential energy is equal to 1 by 2 kx square. And you know that k is what? M omega square. So instead of k, we have written m omega square into this x square as it is. So these two are the formulae of kinetic energy. So here we get, sorry, these two are the potential energy. Yeah? Sorry. So these two formulas are the formulas of potential energy. You have to remember these two formulas. For kinetic energy, you can remember this formula as well as this formula. Now total energy we have to find. So I told you we have to find out energy, means we have to find out here the first kinetic energy. Then second part, start from here, it is a potential energy. And the third part is the total energy. Now total energy is, listen, when you are writing the notes, you can write a step by step also kinetic energy, then potential energy, or you can write here kinetic energy, start here. First point, kinetic energy. So kinetic energy, then potential energy, and then total energy. Total energy is what? Kinetic energy plus potential energy. So this is the kinetic energy. And this is potential energy. Now we have to take some common here. After taking some common term, what common we can take? M omega square we can take common. So in a bracket we get a square minus x square plus x square. This get cancelled. So we get 1 by 2 m omega square a square, and this is the total energy. So if you see the formula of the total energy and the formula of this potential energy. In potential energy here it is x square, and here it is in total energy it is a square. That you can remember. The same formula we can write in term of k also. Is m omega square is k. So k a square is the total energy, half k a square. Or we can write this m omega square, or sorry, omega square a square. We know that it is maximum velocity. So you know that V max is equal to a omega. So if we substitute this formula here, then we get it is half m V max squares. So this is total energy. Yeah? Omega is 2 pi n. If we substitute omega as a 2 pi n in this formula, then we get 1 by 2 m 2 pi n in a bracket square plus a square. Now after solving this, we get this formula for total energy. So by this formula, This n square we can write 1 by t square. It is a period. Frequency is 1 by period, that you know. So here we can write one important conclusion only. And the first conclusion is total energy is directly proportional to. The first point is M. So you can see here E and M, they are proportional. E and M, they are proportional. Second one is total energy proportional to amplitude square. Here also you can see, in this formula also you can see. It is directly proportional to n square, frequency square. It is proportional to omega square, means it is proportional to the frequency square, that you know. You can say here it is a frequency square. So these relations we get. The graph of kinetic energy and potential energy and total energy you can see in a diagram. So here, so this is extreme position. So this is positive extreme position. This is negative extreme position. So where the amplitude is minus A and here it is plus A. Now we can write here some values. So you know that at mean position x is equal to 0. At mean position x is equal to 0. And velocity is maximum. So let me write the formula of kinetic energy at mean position. So you know that kinetic energy formula is 1 by 2 m omega square a square after substituting x is equal to 0. Because kinetic energy formula is, this is kinetic energy formula. In that formula, if we substitute x is equal to 0, we get this is a kinetic energy. And in a potential energy formula, if we substitute x is equal to 0, we get potential energy 0. Means in simple word, at mean kinetic energy is this and potential energy is 0. Now we know the formula of the total energy also. So total energy formula is 1 by 2 m omega square a square. You can see here at mean kinetic energy is 1 by 2 m omega square a square, which is equal to the total energy. So here we can write at mean kinetic energy and total energy both are same. Now the second case is at extreme position. At extreme, you know that x is equal to a plus minus a. If we substitute x is equal to a, at extreme x is equal to a. After substituting the value of x is equal to a, we get kinetic energy is equal to 0. And in potential energy formula, if we substitute this x is equal to a, then we get potential energy is equal to 1 by 2 m omega square a square. Or you can write instead of m omega square, we can write k also. We get formulas for kinetic energy and potential energy at extreme. Now here we can write here at extreme, potential energy and total energy both are same here. That you remember. Now after that, as the particle oscillate, energy changes between kinetic, means energy changes. At the mean position, the energy is entirely kinetic energy. You can see here is the mean position. So here, so this is the potential energy graph. Let I show the potential energy graph by blue line. So this is potential energy graph. You can see this blue line is the potential energy graph. Okay. Means at mean, you can see here at mean potential energy is 0. So here potential energy is touching to the 0. Okay. And at extreme, you can, so or we can say that at extreme potential energy is what, this maximum. You can see here this is extreme, the potential energy is maximum here. So at these two dots, and which is equal to the E means the total energy. Okay. Similarly, I can show here this kinetic energy graph. Kinetic energy I will show it by yellow. So this is the kinetic energy graph. Now kinetic energy, in a kinetic energy graph, you can see here kinetic energy is 0 at extreme. You can see here this is extreme position. So kinetic energy is 0. And at mean position, kinetic energy is maximum, which is equal to the total energy E. So this is the kinetic. So means kinetic energy varies. Now at this position, you can see here this position, at this position, both the energies are same. Now at what displacement both the energies are same, that displacement we obtain. Now we can use the condition if kinetic energy and potential energy both are same. So let I write the kinetic energy formula. So this is kinetic energy formula. Half k a square in a bracket a square minus x square, and this is potential energy formula. Okay? Half m omega square x square. Okay? Or we can write, instead of this we can write k. Then this k and this k get cancelled. So we get formula 1 by 2 a square minus x square is equal to 1 by 2 x square. This 1 by 2 get cancelled. So you get a square is equal to this x square plus x square. So a square you will get 2x square, or x is equal to, or x square is equal to a square by 2. So we get hence x is equal to a by root 2. You can see the formula here. X is equal to a by root 2. Now you note one thing here. When x is equal to a by root 2, both kinetic energy and potential energies are same. So you can see here the 2 points. So here kinetic energy and potential energy, both the energies are same. That time displacement you can see here, we shown in a graph. It is a by 2 minus a by 2 or plus a by 2. So plus minus a by 2. Both the energies are similar. Kinetic energy is equal to potential energy. Once in a board exam question is asked, at what displacement both kinetic energies and potential energy are same, then displacement is equal to a by root 2, amplitude divided by root 2. Now next article is simple pendulum. First thing, what is simple pendulum? So we talk about the ideal simple pendulum. An ideal simple pendulum is a heavy particle suspended by massless, inextensible, flexible string from a rigid support. We are considering massless, inextensible and twistless, we can say that instead of this, twistless string from a rigid support. It is called as ideal simple pendulum. Now we can draw here simple pendulum diagram. This is support, rigid support, and this is string. To this string, if we hang a heavy particle, or we can, instead of heavy particle, one more word we can use, point mass. We can use the word point mass also. Ideal simple pendulum is a heavy point mass suspended by massless, inextensible and twistless string from rigid support is called as ideal simple pendulum. Now, practical simple pendulum. Practical simple pendulum is what? Practical simple pendulum is small heavy sphere. Heavy sphere means you can see here we hang here as a bob. Heavy sphere, or we can say that bob. A small heavy sphere suspended by light inextensible string from rigid support. Generally here, practically the massless string is not possible. We cannot consider massless string. So here massless word we are not used. So practically, instead of heavy point mass, we are considering a heavy sphere or heavy bob. Bob means a metal sphere which is hanged to a rigid support by a string. This is a practical simple pendulum. You can see the diagram here. So this is a diagram. This is rigid support and this is a heavy sphere, or we can say that bob, which is hanged to a support. In the displaced position, when the bob is displaced, means at position B here, the forces acting on the bob, are, the first force is tension in string. The first force is tension in string. Second force is weight, mg. Two forces are acting on this bob. The first force is tension, you can see in a diagram tension T, and second one is weight. We already learned conical pendulum article. In that also two forces are acting on bob. First is tension and second one is weight. Same forces are acting here. Now here we have to resolve this weight mg into two components. You can see in a diagram this weight mg is resolved into two components, mg sin theta and mg cos theta. Okay. mg is resolved into two components. First one is mg cos theta and second one is mg sin theta. These are the two components of weight mg. Now here you can see a diagram very carefully. So this mg sin theta, it pull the bob towards the mean position. This mg sin theta pull the bob towards its mean position. You can see here that this is the direction of the force or direction of the component mg sin theta. So this mg sin theta we can write as a restoring force. So restoring force is equal to mg sin theta. Now we put the minus sign here. The minus sign indicate that as this F increases, means restoring force increases, this theta decreases. Means theta and F, they are oppositely directed. So minus sign is here. Now here theta is very small. So we can write F is equal to mg into theta. Sin theta we are written as a theta. So this is the restoring force. In magnitude we are written. We are not written negative sign because we consider the magnitude. For small angle theta, you already learn in geometry. If this angle is small, then this angle theta is equal to this arc x divided by the length of the string is L, x by L. So here you can see here for small angle theta, we can write it is equal to x by L. Now instead of theta we substitute x by L. So we get restoring force is equal to minus mg into x by L. Or when we want to write only the magnitude, no need to put the minus sign. So this is equation number 1. Now here by this equation we can write. So as here m is constant, g is constant, L is constant. So F proportional to minus x. So we get formula F proportional to minus x. So F is the restoring force, x is the displacement from mean position. So restoring force proportional to displacement, and negative sign indicate that they are oppositely directed. It means that this motion of the bob of simple pendulum is SHM. When we get restoring force proportional to minus x, it means that it is SHM. It is SHM. So restoring force directly proportional to displacement here, and both are oppositely directed. So we can write this is SHM. Now here period of the oscillation of pendulum is given by. Now we have to write formula of period. Now we already derived this formula, period is equal to 2 pi by omega. Or we can write 2 pi upon acceleration per unit displacement. So this is the formula of period. By using this equation 1 is equal to F is equal to minus mg into x by L. By using that we write ma is equal to, you know that F is equal to ma. So ma is equal to minus mg into x by L. Now we can cancel this m and this m is get cancelled. We get acceleration. Acceleration is equal to minus g into x by l. This is the formula of acceleration we get. Now we have to obtain this formula. Listen, acceleration per unit displacement means x we have to shift to the acceleration side. So a by x is equal to minus g by l. In magnitude only g by l. In magnitude only g by l. So here, so this a by x is what? Acceleration per unit displacement. And this acceleration per unit displacement we have to substitute here. In this g by l we have to substitute here. We get expression for period of simple pendulum. Substituting this acceleration per unit displacement in expression of capital T, we get T is equal to 2 pi in a root g by l. Listen here, we substitute only 2 pi as it is. Acceleration per unit displacement is what? G by l. So after writing this in a proper word, we can get the formula 2 pi under root L by G. And this formula is the expression for period of simple pendulum. Now, from equation 1, from this period of simple pendulum, we can conclude following things. The first one is period of simple pendulum directly proportional to square root of length. So it means that the first conclusion is T proportional to square root of length, or we use here capital L, sorry, I can write capital L. So this is the conclusion. Means period depends on length. How it depends? Period directly depends on square root of length. Second conclusion, period of simple pendulum is inversely proportional to square root of acceleration due to gravity. Means T inversely proportional to square root of acceleration due to gravity. So this is the second conclusion by this formula. Now the third one, by formula we can write period of simple pendulum does not depends on mass. You can see here period depends on L on G only. The mass term get cancelled here. So period depends on the L and G, not on the mass. So the third point we are written period independent on mass. It means that in problems question may be asked like this. If this is simple pendulum, so where we use a mass m for the bob, mass of the bob is m. Now the same length string, and if we double the mass, means mass is 2m, then how much is the period? The options are T, 2T, then T by 2, and the second last option is 3T. Listen, if period at the point 1 means position 1 is T, the period in the second position is also T, because period does not depend on the mass of bob. So here also the same period. So this is the conclusion. Period depends on the length. So I consider the length of the string in both the cases is same. So period does not depend on the mass of bob, that you remember. This is third conclusion. And the fourth one, period of simple pendulum does not depend on amplitude. So this is also very important. So let I explain this also. If we consider, so this is simple pendulum. So this is a bob. Now here, so this bob is moving up to this 5 centimeter, and this side also 5 centimeter. Means the amplitude is 5 centimeter. The same simple pendulum, you know that after some time what happened? The amplitude goes on decreasing. The same bob not going to the 5 centimeter, it may goes up to the 2 centimeter. Let I consider it goes up to 2 centimeter. Then also the period is same. If in this case the period is T, the second case also the period is T if the length is same. If the length is same, G is same, means acceleration due to gravity at that place, then the period is same. Means period does not depends on the amplitude. So this is the conclusion of this formula. Next article is seconds pendulum. What is seconds pendulum? Seconds pendulum is a simple pendulum. Seconds pendulum is simple pendulum whose period is 2 seconds. This is very important. If we consider simple pendulum and the period is coming 2 seconds, then it is called as seconds pendulum. Simple pendulum with period 2 seconds is called as seconds pendulum. Now here, you know the formula. T is equal to 2 pi under root L by G. This is the formula for simple pendulum. Now if I substitute period is 2 seconds, T is equal to 2 seconds. Then what we get? For seconds pendulum, period is 2 seconds. Now we get this equation. This 2 get cancelled. And if we obtain formula of L is the length. Then how much length we get? So we get a length is equal to G by pi square. So here we get, after cancelling 2, we get 1 is equal to pi under root L by G. Squaring both side we get, or we squaring both side, 1 is equal to pi square L by G. So by using that, we are written here L is equal to G upon pi square. Now you know the value of G. Value of G everybody know. The value of G is 9.8 approximately, and then pi is 3.14 square. So 9.8 divided by 3.14 square is, I think, 9.84. So it is coming 0.99 meter. So it is coming 0.99 meter, means approximately 1 meter. So simply you can remember here, if the length of the simple pendulum is 1 meter, then we are getting period about 2 seconds. We get period about 2 seconds. Now distinguish or difference between this conical pendulum and simple pendulum. Now here the trajectory. Trajectory means the path followed by this bob is circle. And here the trajectory is what? It is a vertical circle like this in simple pendulum. Second one, kinetic and gravitational potential energy constant. But here kinetic and gravitational potential energy are interconvertible. The energy is conserved, but they are interconvertible because it's a vertical circular motion. We learn vertical circular motion article also. In that, kinetic energy and potential energy are interconvertible. Next one, you can see here, horizontal component of force due to tension is necessary, and here tangential component of weight is governing the force. Means here we know the restoring force we learn. Now here period is given by this formula, and it is given by this. For same length, this period is greater. Period of the simple pendulum is greater. Other 2 points also you can see here. In today's lecture, we start angular SHM. First thing we learn what is angular SHM. Then we learn differential form of SHM. Similar to the linear SHM, we have to learn this article. So you can see a diagram here, a metallic disc which is hanged to a rigid support by a wire or by a string. If the disc is slightly twisted about the axis, you can see here the direction of the twist, and released, it performs rotational motion in clockwise and anti-clockwise direction. So you know that when we pull the bob of the simple pendulum towards one side and release it, then it start moving to and fro about its main position. Similar to here, as once we turn this disc slightly, then it start its motion, means it is clockwise motion and anti-clockwise motion. Such oscillations are called as angular oscillation, and such type of motion is angular oscillation. In such type of oscillations we can say angular oscillation. It is also called as torsional oscillation. This motion is governed by restoring torque. You know that when we twist this uh, wire, or when we apply some here, the force in clockwise or anti-clockwise direction and release it, then in this wire some restoring force is developed, and because of that restoring force, the clockwise and anti-clockwise motion of the wire, this disc we can see. And basically, a restoring torque is developed here, which is in opposite to the angular displacement. Next article is differential equation of angular SHM. Before proceeding towards the differential equation of angular SHM, let I tell you, differential equation of linear SHM is d square x by dt square plus omega square x is equal to 0. So this is a differential equation of linear SHM. For linear SHM, this is a differential equation. Or the same equation we can write d square x by dt square plus k by m into x is equal to 0. So this k by m is equal to the omega square. This is also a differential equation in another form. Now let me learn differential equation for angular SHM. So in angular motion, restoring torque acting on body for angular moment, angular displacement theta is given. Listen, angular torque, this restoring torque depends on how much is the angular displacement. How much is the angular displacement? Based on that, angular torque depends. So we can write here, torque depends on the angular displacement. So we can write torque proportional to theta. And here minus sign. You know that in linear SHM we written here F proportional to minus x. Similar manner. So here in this kind of motion, the analogous term to the force is torque, and analogous term to the displacement is the angular displacement. It is theta, and this minus sign as it is. So torque proportional to minus theta. And when we put the sign is equal to sign, then we have to write constant, and C is the constant here, constant of proportionality. Minus sign indicate that this torque and theta, they are oppositely directed. Both are oppositely directed. Now after this, we also know if I is the moment of inertia. We learn moment of inertia. If I is the moment of inertia acting on body, then torque is given by the moment of inertia and the torque relation that we already derived. Torque is equal to I alpha, where alpha is the angular acceleration. So we will get here two formulas of the torque. This is the first formula. This is second formula. Now we can equate these two formulas. So we get I alpha is equal to minus C into theta. One side of both the equation is same. So we equated these two equations. Now after that, alpha is what? Acceleration. You know that linear acceleration is what? dv by dt. Then d by dt as it is. Instead of v, we can write dx by dt. So acceleration we get d square by dt square. Similar manner, you know that alpha is equal to what? D omega by dt. Then d by dt as it is. Omega is what? D theta by dt. Now what we get? D square theta by dt square as a alpha. Now let me try to simplify it by using that. So alpha is equal to, we substituted this. d square theta alpha is equal to d square theta divided by dt square, and this I as it is equal to minus c into this theta. Now we have to simplify this equation to get differential equation. Now we transfer this I to this right hand side. So here it is divided to c minus c and theta. So we get a next term d square theta divided by dt square is equal to minus c theta divided by I. Okay. In this alpha is equal to, means d square theta by dt square is alpha. Alpha is equal to minus c into theta divided by I. This formula you. C and I are constant. So we can write here, if C and I is constant from this formula, then we can write alpha proportional to minus theta. Just we written torque proportional to minus theta. Similar manner we get alpha proportional to minus theta. This angular acceleration, means this alpha, depends on angular displacement. Angular acceleration depends on angular displacement, means alpha depends on theta. But both are in opposite direction, so we put the negative sign. Hence, this is oscillatory motion, and this motion is called as angular SHM. Time period of angular SHM is given by, the time period is similar here. T is equal to 2 pi by omega, which is similar to the previous, means similar to this linear SHM. As well as we know the formula, T is equal to 2 pi divided by under root angular acceleration per unit displacement. So here in linear SHM, we are written here, T is equal to 2 pi upon linear acceleration per unit displacement. We are not use this word angular. But when we are talking about the period of this angular SHM, it is given by this formula. Therefore, angular SHM is defined here. Angular SHM is defined by this formula, or we can use this formula, torque proportional to this minus theta. So it is defined as oscillatory motion of body in which torque, two words we use, torque or angular acceleration, means alpha or disto, directly proportional to angular displacement, and direction is opposite to that of angular displacement. So direction is opposite, so that's why negative signs come. Question may be asked, define angular SHM. You have to write this definition. Next article is magnet vibrating in uniform magnetic field. Now we consider one magnet which is placed between the magnetic field. Then because of interaction of two magnetic field, it vibrates or it oscillates, we can say. And that motion we have to study. You can see diagram here. This is the magnet. This is the N pole. This is S pole. Now this is the force acting on the N pole is mb. Now you know that electric intensity formula is F by Q. Similar manner, magnetic field formula is F by M. So F is equal to mb. This is the force acting on a pole whose strength is M. So here, force acting on this S pole is mb, or we can put minus mb. Okay, because it is opposite to this force. Or the pole strength of S pole is minus m, so we can put minus mb also. Let me consider mu is the magnetic dipole moment. We can use capital M also for magnetic dipole moment. But here in this chapter oscillation they use mu. So I use here mu for the magnetic dipole moment. But in one of the chapter related to the magnetic field we use capital M also. So mu is the magnetic dipole moment. B is the magnetic field. In deflected position, restoring torque acts on magnet that tends to bring back to its equilibrium position. Magnitude of the torque is given by, so torque is equal to mu b sine theta. In physics 2, I told you torque is given by formula mb sine theta. So this is the formula of torque. Torque acting on dipole, magnetic dipole. Torque acting on electric dipole is Pe sine theta. Electric dipole. And this is on magnetic dipole. So remember, torque acting on electric dipole is Pe sine theta. P is what? Magnetic dipole moment. E is electric intensity and the sine of theta. Here M is the magnetic dipole moment, B is the magnetic induction and sine of. So instead of capital M here we use mu. So torque acting is given by formula mu B sine theta. Theta is very small, so sine theta we can write as a theta. So instead of sine theta we use theta. So we get torque is equal to mu B into theta. For clockwise angular displacement theta, restoring torque is in anti-clockwise. So restoring torque is always opposite to the angular displacement because we are written here torque proportional to minus theta. So they are oppositely directed. Or we know the formula of torque is another formula, torque is equal to I alpha. Or they are oppositely directed, so we can write here torque is equal to minus mu b into theta. Torque is equal to minus mu b into theta. So they are oppositely directed. Theta and this torque, you can see here torque and theta oppositely directed. So here the torque is coming, here theta is coming. They are oppositely directed, so we put the minus sign. I is the moment of inertia in above formula, alpha is angular acceleration. Now alpha is equal to, by using this formula we can write alpha is equal to minus mu b upon I into theta. Only we transfer this I to this right hand side. Then we get this formula. Now here this mu b divided by I is constant. So we can write this alpha proportional to minus theta. And therefore motion of this magnet is angular resistance. So here we get this alpha proportional to minus theta. The motion, the oscillatory motion where angular acceleration proportional to angular displacement and they are oppositely directed, then that motion is the angular resistance. So therefore here it is written they are proportional, oppositely directed, therefore it is the angular resistance. And its magnet will form angular resistance. Now by using this formula we can write alpha upon theta is equal to mu b upon I. We are not written negative sign because we consider only magnitude. In magnitude only we are written this. And this is what alpha divided by theta is angular acceleration per unit angular displacement. Hence we can write angular acceleration per unit angular displacement is equal to mu into b divided by I. And by using that we can find out period. Period is given by formula. You can see the formula of period. 2 pi upon angular acceleration per unit is angular displacement. And you can see here this term is here. Now let me substitute this term angular acceleration per unit displacement in this formula of period. Then we get T is equal to 2 pi under root alpha upon theta. Alpha upon theta means this angular acceleration per unit displacement. Let me substitute this. We get an expression for period of this magnet. T is equal to 2 pi under root I upon mu into B. And write this like this. Theta upon alpha. Or we can write 2 pi I upon mu. This after substituting. So this is the expression for period. I hope you understood this. Now next article is damped oscillation. Everybody know that what is oscillatory motion means to and fro motion of object is called as oscillatory motion. But what is damped oscillation? Let I tell you simple example here. So when amplitude decreases, then that oscillation is called as damped oscillation. So you can see here the definition. Periodic oscillations of gradually decreasing amplitude. So this word is very important. Gradually decreasing amplitude are called damped harmonic oscillation. And that oscillator is called as damped harmonic oscillator. Now you can see here diagram also. So in a diagram, this is spring. This is a block. And here some liquid is there. And in that liquid you can see this vein. Okay. When we give oscillation to the block, then you know that if this vein is absent, if this part is not there, then block start oscillating to and fro. But here this vein is there and it is placing liquid. So liquid opposes this motion of the block. Means it produces damping. So the amplitude of the block goes on decreasing gradually. So therefore this type of oscillatory motion of the block is called as damped oscillation. Now here damping force. If we consider damping force is Fd, it depends on nature of the surrounding medium, means it depends on which type of medium inside this, maybe water or any other liquid, and directly proportional to the speed of the vein. The speed of the vein also decides how much the damping force is there. So here we can write the relation between damping force and the speed. They are proportional. So here we get a relation, this damping force proportional to the speed, and they are oppositely directed. Okay, they are oppositely directed. Therefore, the minus sign is coming. So we get a relation here. Damping force is equal to minus B into V. And this B is a constant of proportionality. That's it only. Okay, B is a damping constant. Negative sign indicate that this, you can see here, this damping force Fd opposes the velocity. Or they are oppositely directed. Listen, as damping force increases, velocity decreases. They are opposing. Damping force opposes the velocity, and because of that, negative sign is coming. Also, we can say here, the spring constant is K. If spring constant is K, then force on the block from the spring is. And the force, you know that here we learn in the previous article, F proportional to minus X. Then we can put here constant, F is equal to minus K, X relation B. And that here it is written. Yeah, this restoring force is equal to minus K into X. This K is this force constant. K is a constant and it is called as force constant. In this case, one more force is acting and it is a gravitational force. But we are considering gravitational force is neglected in this case. So when we are deriving the formula, we are not considering any gravitational force here. We consider this damping force and this restoring force due to the spring. Or force due to the spring basically. Now, we can write here total force acting on the mass or on the block is. Total force is what? damping force is in the downward direction, means it is a damping force plus is force due to this spring. Let me substitute both the formulas. So we get MA is equal to damping force and force due to the spring or force restoring force we have to substitute. So MA is equal to this damping force is minus BV and Fs is minus Kx. So we substitute, we get this formula. Now we transfer this minus BV and minus Kx towards left hand side. So we get a formula. MA plus BV plus Kx is equal to 0. So acceleration we can write like this. You know that A is equal to dV by dt. Then d by dt as it is. V is what? Dx by dt. So acceleration we can write d square x by dt square. This is acceleration. So you know that velocity is what? Dx by dt. Okay, that we substitute here. This is the acceleration and this is velocity we substitute. Then we get, this is the equation and this is the differential equation of this motion. This differential equation of damping motion. Now we have to write solution of this equation. The solution of this equation is x is equal to a e raised to minus bt divided by 2m into cos of omega t plus phi. Omega t plus phi. Now here solution, it's a mathematical part. So solution, how we get solution, that I am not explaining here. But here you remember, the solution is this. A is the amplitude, E is the exponential term. Why the exponential term is there, that I will tell you. Because the amplitude goes on decreasing in exponential manner. So the E raised to something we are written. So this is the amplitude. So this basically is the total amplitude. Okay, at any time instant t. And this cos omega t plus phi. Here AE minus raised to minus bt by 2m is the amplitude. As shown in the displacement against time graph, the amplitude decreases with time exponential. You can see here, initially amplitude is A. Then as time increases, amplitude start decreasing, and finally it stops. So here we can see here exponential decay in the amplitude. Therefore here e raised to something we are written. You can see here, so this is the displacement against time graph that you can see very carefully. Omega is the angular frequency and it is given by this formula. Similar manner, we can write periodals. Period, you know that T is equal to 2 pi by omega. Only we substitute omega, then we get a formula of period. Let's see MCQ number 1. A particle perform linear SHM starting from mean position. Its amplitude is A, capital E. Period is T. At the instant when the speed is half the maximum speed, displacement E. Now here they given one condition. The speed is half the maximum speed. This is very important sentence. And here they given speed is equal to half the maximum speed. Now we have to substitute the values. Speed is given by formula omega under root a square minus x square is equal to 1 by 2. Maximum speed is given by formula a omega. Now you cancel the common term, simplify the equation, you will get the answer for x. Now we cancel here omega from both the sides. Now squaring both sides, a square minus x square is equal to a by 2 square. So we get here a square minus x square is equal to a square by 4. Now here a square minus a square by 4 is equal to x square. Now it is coming 4 minus 1, 3a square by 4 is equal to x square. So we have to find out x. Then root 3. Root a square is a. Root 4 is 2 is equal to x. And this is the answer. You can see this in option number A. The answer for this MCQ is option A. Now we start the next one. MCQ number 2. MCQ number 2. A body of mass 1 kg. So mass is given. Performing linear ascension, its displacement x in centimeter at time t is given by x is equal to 6 sine 100 t plus pi by 4. Maximum kinetic energy of body is. So maximum kinetic energy is equal to 1 by 2 m v max square. So 1 by 2 m maximum velocity is given by formula a omega square. So let me substitute here the values. 1 by 2 1 by 2 m so how much is the m that we decide? So m is 1 kg, and this equation we have to compare with the standard form. X is equal to a sine omega t plus phi or alpha we can use. So here omega is 100. So 1 by 2 into 1 into a is 6 multiplied by omega is 100 square. So it is coming 1 by 2. 6 square is 36. 100 square is 10 raised to 4. So we get answer here. 36 by 2 is 18 into 10 raised to 4. Is in erg. Because everything, no, not in erg. Let me correct here the unit. Listen, here we have to convert everything in the same system that we are not done here. So we have to convert this. Mass is 1 kg. 1 kg means 1000 gram. So that I am not converted. This x is already in CGS. So here we substitute 1000. 1000 means 10 raised to 3. So 10 raised to 3. So here we get 18 into 10 raised to 7. This is in erg because we use everything in CGS. So you know that 1 joule is 10 raised to 7 erg. And here you get 10 raised to 7 erg means the joule. So the answer we get 18 joule. Therefore, option D is the right answer for this question. MCQ number 3. Length of seconds pendulum. Seconds pendulum means pendulum with period 2 seconds. On surface of earth is 1 meter. Length of second pendulum on earth is 1 meter. Its length on the surface of moon should be. Acceleration due to gravity on moon is 1/6 of that on earth's surface. So here period is given by formula 2 pi under root L by G. If we substitute T is 2 for seconds pendulum, and if we simplify this equation, then we get 1 is equal to pi square L by G. So we get L is equal to length of the pendulum is equal to seconds pendulum is equal to G upon pi square. Okay. Now here on earth, the given G upon pi square is equal to 1 meter. It is given. On moon, we have to find out how much it is. How much is the length? Okay. On moon, L is equal to G upon pi square, but G on the moon is given 1 by 6 G on earth divided by pi square. So we can write 1 by 6 G by pi square. And this G by pi square is given, it is 1. So 1 by 6 multiplied by 1 is 1 by 6. So 1 by 6 is the answer for length on moon. Therefore, option A is the right option for this question. MCQ number 4. Two identical springs of constant K are connected first in series and then in parallel. A metal block of mass m is suspended from their combination. The ratio of their frequency of vertical oscillation will be in the ratio. Now let I tell you one thing here. The formula for period is 2 pi by omega. And everybody know that omega is under root k by m. So P is 2 pi in a root m by k. So frequency is 1 by period. So we get 1 upon 2 pi under root. Instead of m by k, it is k by m. This is expression for frequency. Now here, m is constant. Mass of the block is m. It is a fixed. Pi is a constant. So frequency proportional to square root of k. And you have to find out ratio of frequency. So ratio of frequency is frequency 1 divided by frequency 2 is equal to in a root k1 divided by k2. Now what is k1? Force constant for the first combination is k1. Now let I show you here for first combination. First combination is what? Series. Means here, so this is a support, this is the first spring, and this is second spring, and this is a block whose mass is m. Now here the constant, force constant is k, here the force constant is k. In second situation, this is the second situation. So where it is in parallel, means this is the support, this is the first spring, this is second spring, they are parallel and a block is attached, the same block whose mass is m. Now here again force constant k, here the force constant k. Now we can do one thing here. We consider the force constant in this case is k1. Okay, and here in this case is total force constant is k2. And then we have to substitute k1 and k2 in this formula. Now let I explain how we get. When two springs are in series, that time force constant is given by formula. Let I tell you, 1 by k is equal to 1 by k1 plus 1 by k2. This is the formula. You solve this and you will get force constant in this series combination. I will use here, instead of k1 and k2, I will use force constant in series divided by force constant in parallel. So here in series and here it is in parallel. That we have to substitute in this formula. Okay. Now I will solve this one. So both the force constant is K. So 1 by K plus 1 by K. We get 2 by K. It is 1 by Ks. So Ks is equal to K by 2. So this is the force constant for the first combination. Second combination, the force constant K in this parallel combination is K1 plus K2. So K1 is K, K2 is K. So K plus K is 2K. So we get this force constant is 2K. Now we substitute these values in a formula and we try to simplify it. So under root Ks is K by 2 and here it is 2K. Simply we can write F1 by F2 is equal to in a square root K by 2 multiplied by 1 upon 2K. So K get cancelled, we get 1 by 4 in a root. 1 by 4 means 1 by 2 is frequency ratio. Therefore, the answer for this question is 1 by 2. Ratio of the frequency is 1 by 2 and 1 by 2 is option B. Question number 5. Graph shows variation of displacement of particle performing SHM with time. You can see displacement versus time graph. Which of the following statement is correct from the graph? Now let me check the statement 1. Acceleration is maximum at time t. So you know that acceleration is given by formula omega square x. So when x is maximum, that time acceleration is maximum. And at t, you can see here, at t x is 0. So acceleration is 0. So this option is not coming right option. Next one, force is maximum at t 3t by 4. The force is equal to ma. Okay? This is the formula for force. And if acceleration is maximum at 3t by 4, then force is maximum. So maximum force is maximum acceleration, and maximum acceleration formula is omega square a. Or you know that this is acceleration. This is acceleration. When x is having a value a, that time acceleration is maximum. And you can see here at 3t by 4 means here. So here the value of x is a by 2. Sorry, it is equal to a minus a, means magnitude wise a. So here force is maximum here at 3t by 4. So this is the right answer for this MC. Now velocity, next one also we discuss, velocity is 0 at t by 2. This is t by 2. This is the mean position. Listen, this is the mean position. Because at t by 2, x is 0. X is 0. X is 0 means velocity is maximum, not 0. So this is wrong. Kinetic energy equal to total energy. Kinetic energy is equal to total energy only when x is equal to a by root 2. When we learn the graph, that time we derive this. So t by 4, you can see here t by 4, x is equal to a. So kinetic energy and potential energy are not equal. So this option D is also wrong option. So correct option is option B. And it is force is maximum at 3t by 4. Now problem number 8. At what distance from the mean position is the speed of particle performing SHM half its maximum speed? Speed is half of the maximum speed. Let's see, and here they given the path length. Listen, when particle is performing SHM, so this is the main position, this is extreme, this is also extreme position. Here x is equal to 0, here x is equal to plus a, and here x is equal to minus. So this total distance is the path length. You know that this is a and this is a. So path length is 2a. It means that 2a is 10 centimeters. So a is 5 centimeter is the amplitude. Okay, you can see here the given. Now here the given condition, speed is half the maximum speed. So speed is equal to 1 by 2 Vmax. Now we substitute formula of V and formula of Vmax. Then we cancel the common term. Okay? So A is 5 here. Now we substitute common term. Means we substitute the formula of V here and Vmax, yeah, A omega. Again, this divided by 2 as it is. Now you can cancel the common term and simplify this equation for x. Now here the omega get cancelled. After that we solve it for x and we get x is equal to root 3 by 2, which is similar to the MCQ number 1. Then root 3 by 2 is this 0.866 and this amplitude is 5. So we get displacement or distance is 4.33 centimeter. Question number 9 from exercise. In SI unit, the differential equation of SHM is d square x by dt square is equal to minus 36x. Find frequency and period. Let's see the solution of this equation. So this is a given and we compare this equation with the standard. So you know that standard differential form is d square x by dt square plus omega square x is equal to 0. This equation we can write like this. So by using that you can write omega is how much? Omega square. Omega square is 36. Omega square 36. So omega is root 36 means 6 radian per second. As you get omega, then period is 2 pi by omega and frequency is 1 by period. Two calculations you have to do. So this equation is the given equation and this is the standard form. We compare both the equation. After comparison, we get omega square is 36. It means that omega is 6 radian per second. Now we have to find out frequency. So omega is 2 pi f. So frequency is omega upon 2 pi. Now let me substitute omega and we solve this one. Omega is 6. So 6 upon 2 into this pi is 3.142. Then we get 6 upon 6.284. And this division is coming 0.9548 Hertz. And this is the frequency. Now we have to find out period. Period is reciprocal of frequency. It is 1 upon 0.9548. Or you can write like this well. So this is also frequency. So 6.284 divided by 6 is the period. After solving this, we get period 1.047 second. This is period. Now question number 10 from exercise. A needle of sewing machine moves along a path of amplitude with a frequency 5 Hz. Find its acceleration 1 by 30 seconds after it has crossed the mean position. Means time is given. Now let me enlist all the given parameter. So these are the given. Means amplitude, frequency and time. and you have to find out acceleration. So you know that acceleration is what? Omega square x. This is the formula of acceleration. Now x is not given anywhere, but here they are given frequency. So we can write x is equal to a sine omega t. Now, a is given, frequency is given, you can find out omega. So omega is 2 pi f. Okay? And time is given. So everything is given, then you can substitute. Now let I explain here. I hope you understood the hint. Now let's see the detailed solution here. So here omega is 2 pi f and frequency is phi. So if we substitute f is phi, then we get omega 10 pi radian per second. Therefore, the magnitude of acceleration, you know that acceleration is omega square x, but x is not known. So we substitute x is a sine omega t. Then we substitute omega, then amplitude, as well as, so the steps are here. So we substitute here omega, amplitude, and this sine omega t. So a extra here. Then after solving this, we get 10 pi square sine pi by 3. 10 as problem number 11 from exercise. Potential energy of particle performing linear oscillation is 0.1 pi square x square joule. The mass of the particle is 20 gram. Find frequency of oscillation. We have to find out frequency of oscillation. Now here given. So this is potential energy. This 20 gram is the mass that you have to convert into the kg. So you can write 20 into 10 raised to minus 3 kg. And frequency we have to find out. In a formula of potential energy. So solution here, potential energy is this, mass is this. So potential energy is given by formula 1 by 2 m omega square x square. Now here omega we can write. Omega is 2 pi into frequency 2 pi f. So it's omega square. So 4 pi square f square we are written. Now potential energy is given in term of x. So here when we substitute potential energy, then x square get cancelled from both the sides, and you have to solve this equation for frequency. As we substitute the value of this potential energy, then this x square get cancelled, pi square and this pi square get cancelled, as well as this 2 2s are 4. We get here, after simplification, 2 m f square is equal to 0.1. After this we get this step. Now we have to solve this for frequency. So let me substitute in a formula of frequency. F square is equal to 0.1 divided by 2m. Let me substitute here values and we do the calculation to find out answer. So 0.1 divided by 2 into
20 into 10 raised to minus 3. That 20 into minus 3 we can write 2 into 10 raised to minus 2. And this point 1 we have written 1. So here it is 20. So we have to solve this. And after solving this we get f square is 2.5. Means frequency is root 2.5. Root of 2.5 is coming 1.581. And this is the answer for the frequency. Now problem number 12. The total energy of body of mass 2 kg. So this is a mass. Performing SHM is 40 joule. This is total energy. Find speed while crossing center. So speed at center is the maximum. So you have to find out maximum speed. So V max is question mark. Let me write the given here. Mass and total energy is given. Now we can use a formula of total energy. 1 by 2 m omega square 1, or we can use the directly here formula. So at the center, so body having only a kinetic energy. Means at mean position, the total energy is equal to kinetic energy. So we can use the formula of kinetic energy. Speed of the body while crossing the center of the path is maximum. Total energy entirely the kinetic energy, or we can write, so total energy E is equal to kinetic energy. And here kinetic energy is given by formula 1 by 2 mv max square. Now here maximum velocity we have to find out. Everything is given. So v max is equal to under root 2e by m. Now let me substitute the values. So we get under root 2 into 40 divided by 2. 2 get cancelled. So here root 40 is coming 6.324. It's a velocity, so meter per second. So this is the speed while crossing center of the path, and speed at mean position. Now problem number 13 from exercise. A simple pendulum perform SHM of period 4 seconds. This is capital T. How much time after crossing the mean position will the displacement of bob be 1/3 of its amplitude? So x is equal to a by 3 they given. So displacement is, or 1 by 3 of amplitude you can write. So after crossing mean position, so we start with the displacement formula. If particle start from mean position, displacement is given by x is equal to a sin omega t. So here t is 4 seconds, x is a by 3. So displacement of particle starting SHM from mean position is given by this formula. Now in that, omega is not given, but here period is given. So we can write omega is 2 pi by t. Then we get formula of displacement is equal to a sine 2 pi by t into t. Tension here. So x we substitute a by 3. Then here a by 3, sorry, a and a from a by 3 get cancelled. So here we transfer this sign to this side. Sine inverse of 1 by 3 means this 0.333. Just I told you the value of this. It is coming 19.47 degree. Okay. Now we can simplify this for small t. Period capital T is 4. And pi we can substitute 180. Or we can do one thing, we can convert this into the radian and then we can substitute pi 3.14 also. Okay. Now here they converted. No need to convert this. We can write like this: small t is equal to 19.47 into capital T by 2 pi. So 19.47 multiplied by capital T is 4 divided by 2 into pi is 180 degree. So if you solve this, whatever the answer you are getting, it is the time. Or you can convert this quantity into the radian, and then you can substitute pi as a 3.14, or this pi get cancelled. In that way also you can do. So you are getting the same equation. Same equation you will get. Now after solving this, we get 19.47 divided by 90. So you can see here it is 2 2s are 4. So 2, here it is 90. So 19.47 by 90 we get. And it is coming 0.2163. Question number 14 from exercise of oscillation. A simple pendulum of length. So here length is 100 centimeter means 1 meter. Perform SHM. Find restoring force acting on its bob of mass 50 gram. This is a mass. So 50 gram means 50 into 10 raised to minus 3 kg. Or you can write 5 into 10 raised to minus 2. When displacement from mean position is 3 centimeter, so it is a x. So it is 3 into 10 raised to minus 2 meter. And what we have to find out? Restoring force. So restoring force, so given we enlist here, so length, so it is equal to 1 meter. 50 gram means 50 into 10 raised to minus 3. It means that 5 into 10 raised to minus 2. X is 3 centimeters, so we can write 3 into 10 raised to minus 2 meter. And G we can use 9.8. So we know that restoring force is F is equal to minus mg sin theta is there, but we are not using minus sign. We consider only the magnitude here. This theta is very, very small, so we can write F is equal to mg into theta. Now here theta also we can write x by L. So we can write this formula mg x by L. Now we substitute, everything is given. We have to substitute and we have to solve it for F. After substitution of the values and doing the simple calculations here, we get this is the force 1.47 into 10 raised to minus 2 Newton. लक्ष जर आन्सर नेहमी आल्यानंतर you try to write it in standard form. As you get the answer, immediately you try to write down in standard form. Now problem number 15 from exercise. Find change in length of second's pendulum if acceleration due to gravity at a place changes from 9.75 to 9.8 meter per second square. And you have to find out change in length. First thing, you know that period second's pendulum means t is given 2 seconds. So as we substitute t is 2 seconds, then we get length is equal to g by pi square. So you have to find out change in length. So you find out L1 and L2 by taking this first, this is G1 and this is G2. Find out L1, L2, and the change in the length is the difference in the length. So here you can see here the given G1 is given, G2 is. Then after that you use this formula. By using that you will get L1 and L2, and then difference you have to take. Now let me find out L1 by using a formula G1 by pi square. So we get 0.9876 meter as a L1. Similar manner we find out L2, G2 upon pi square. 0.9927 is L2. Now change in length is difference in the length. L2 minus L1. As we take L2 minus L1, we get 0.0051 meter as a change in length. Question number 16. At what distance from mean position x is equal to question is the kinetic energy of particle performing SHM of amplitude 8 centimeter 3 times the potential energy. You have to use formula kinetic energy is 3 times the potential energy. And then you have to substitute kinetic energy formula, potential energy formula. You have to cancel the common term and you have to find out x. So kinetic energy is 1 by 2 m omega square a square minus x square, and potential energy is 3 multiplied by 2. 3 multiplied by 1 by 2 into this m omega square x square. Cancel the common term and simplify this equation for x. You will get answer. So answer for this question is 4 centimeter. Displacement is amplitude by 2. Amplitude is 8. 8 by 2 is 4. Now question number 19 from exercise. They given here x is equal to a sin omega t plus b cos omega t. Here a, b and omega are constant. Prove that amplitude is given by this formula. Now here we have to adjust here the standard form. So x is equal to a sin omega t plus b cos omega t. Now the same equation we can write here. A sin, this omega t we can write omega t plus 0. And this cos, we are written cos in term of sine. So sin omega t plus 90. You know that sin omega t plus 90 is cos omega t. Comparing this equation with standard form, the standard form is this. We learn composition of SHM. In that composition of SHM, we learn this is standard form. Now, as we compare with the standard form, you come to know that how much is A1. A1 is A, A2 is B, alpha 1 is 0, alpha 2 is 90. So we get this A1, A2, alpha 1, alpha 2. Now, resultant amplitude is given by this expression. In composition of SHM, we obtain resultant amplitude formula under root A1 square plus A2 square plus twice A1 A2 cos of alpha 1 minus alpha 2. Now let me substitute the values. So A1 is A, A2 is B. Okay, so A1 square plus B square plus 2AB into cos of alpha 1 is 0 and alpha 2 is 90. So we get cos 0 minus 90. So cos 0 minus 90 is cos minus 90. Cos minus 90 is similar to the cos plus 90. So we can write this. Now cos 90 is coming 0. So this term get cancelled. 0 into 2ab 0. So we get under root a square plus b square. And this only we have to prove here. Hence